Okay, so the next problem we have is integral of cot inverse secant x minus tan x dx, and x belongs from where to where, minus pi by 2 to 3 pi by 2, right? So just see how we can solve the problem. Cot inverse x, cot inverse, not x, cot inverse secant x can be written as 1 upon cos x minus this can be written as sin x upon cos x. So what we are doing, the first step only we are changing the secant x and the tan x in the form of cos and sin, right? And now the next step I can write as cot inverse, and in the bracket cos x will be the denominator, and this will become what, 1 minus sin x and dx. Now sin theta we can know, sin theta can be written as cos 90 minus theta. So this part of the sin, no, cot inverse 1 minus, I can write as pi by 2 minus x. Only writing cos 90 minus theta will become again sin x, no, so only this change I am making. And this part, no, cos x I can write sin pi by 2 minus x, that is sin 90 minus theta is again cos x. Now why we are doing this, it has some benefit, right? 1 minus, this is 1 minus cos theta, so 1 minus cos theta, this can be written as 2 sin square x by 2, right? So this assume as theta or x, whatever you want to assume, right? And this can be written as, no, cot inverse 2 sin square, and when I say x by 2, it means that part of the theta you have to divide by 2. So pi by 2 will actually become what, pi by 4 and minus x by 2. Is it? Yes. And in the bottom, no, in the bottom what I will get, no, this is sin pi by 2 minus x. So this can be break as what, sin 2 theta, and sin 2 theta we can write as 2 sin theta into cos theta, because this angle will become half then, right? Assume this as 2 times of any angle. So this will become what, 2 sin, and the half of this angle will be what, again pi by 4 minus x by 2 into cos of, this will become pi by 4 minus x by 2, right? I hope you got this. In the first thing we have done 2 sin square x by 2, that is the complete part, and the half of the angle we are making now, so pi by 4 minus x by 2, and this part we are making sin 2 theta, we are assuming it as sin 2 theta, so this will become 2 sin theta by 2 into cos theta by 2, right? Now you see this part of sin, no, this will cancel the square, this 2 will cancel this thing. So in the numerator I will be getting only sin pi by 4 minus x by 2, and in the denominator I will be getting cos pi by 4 x by 2, and we know it is very simple, sin by cos I can write it as tan. So simply I am writing first step what I am getting. I can write here sin pi by 4 minus x by 2, that is all left in the numerator, divided by cos pi by 4 minus x by 2 in the denominator, right? So sin by cos is simply nothing but tan. So finally I am getting the integral of what, cot inverse tan and pi by 4 minus x by 2 dx. Now one more thing we know, that tan inverse x plus cot inverse x is actually equal to pi by 2. So if I assume this as cot inverse of something, so cot inverse of something, can I write pi by 2 minus tan inverse of that part, because we know, right, tan inverse of x plus cot inverse of x is equal to pi by 2. This we know, right? So cot inverse of that part of something, no, I am writing at pi by 2 minus tan inverse of what? That part is what? That part is nothing but tan inverse of pi by 4 minus x by 2 and dx. Now see, tan inverse of tan, this part will become what? I will be only getting pi by 4 minus x by 2. So what is left? Tan inverse of tan, this will become pi by 4 minus x by 2, and I think we should give a bracket, right? So pi by 4 minus x by 2. When you open the bracket, it will become pi by 2 minus pi by 4, and this will become plus x by 2. So pi by 2 minus pi by 4 is what? Again pi by 4, and this will become plus x by 2. So this integral will become what? Pi by 4x plus x square by 4 plus c. So final answer I will be getting is pi by 4x plus x square by 4 plus c. This will become x square by 2 and one of the 2 was already there, so x square by. So final answer is pi by 4 plus x square by 4 plus c. So I hope you got it.